Hi everyone, it's Albin here. Welcome back to my YouTube channel. Today in this video, I'll be talking about some design principles that helps the developers to build the maintainable and scalable application and robust object-oriented applications, and which will be very helpful while developing an application or while we are working in an industry, or to helps to build maintainable and scalable scale applications. So in this video, I will be talking about the solid principles. So I hope some of you may have heard about this five rules or the five set of design principles that used in software development. So today I will be discussing in detail about the solid principles. So before getting into that, first we need to know about the what is actually solid principle and what does that mean, and what are the meanings of the letters included in the word solid. Okay, so at first I have already said that the solid principles are nothing but it's just a set of rules that helps the developers to build large applications which are maintainable, scalable, and also flexible and robust. So which are very helpful for building such large scale applications. So what does this mean, or what does this solid or SOILID, what does these spellings means? That it is each of these letters in the word contains specific meaning that refers to. S refers to single responsibility principle. So and O is represents the open for modification but closed, open for extension but closed for modifications, and the letter L means that Liskov substitution principle, and the letter I represents the interface segregation principle, and the last one and last and final and last and most important principle is that dependency inversion principle, which is also may hear about some clean architecture developers, because in clean architecture it mostly follows on the documentation, also the documentation by Robert C. Martin or Uncle Bob. He also wrote in his personal documentation, or sorry, in the clean architecture official documentation about the dependency inversion principle. Actually, the clean architecture itself follows the dependency inversion principle. So I will explain that in detail later in this video. So what does this all these principle or this five set of rules mean is that the first one, let's start from the first. Okay, so first is that S, or the single responsibility principle. So as the name suggests, you may be got an idea of what does this S, or the single responsibility principle mean. Is that the single responsibility principle means the a class should only have a single responsibility, or we can say it in another way, like a class should only have a one reason to change. Okay, so that is what is meant by the single responsibility principle, which means that each and every classes, I am saying in an object oriented way, you can also apply that in a functional. If you are a functional programmer, you can also apply that in way a class or a function should only contain one reason to change. Okay, so if we are writing an authentication module, we have the user login, sign up, register, and so on so things. So we may wrote code in a single function, or in a single file, or we are writing in an object-oriented way. We wrote all this authentication code, or the authentication functions in a single class. So the class contains multiple responsibilities. The class is responsible for the user login and registration and OTP verification and all. So this is violating the first principle in the solid. So a class should only contains one responsibility, and which should only contain one reason for change. So that is what mentioned. That is what meant by the first principle in the solid. That is single responsibility principle. Again, the single responsibility principle meant for a class should only contain one reason for change, or we can say that a class should only responsible for one thing, or one certain case. Okay, so that is what meant by the single responsibility principle. And moving on to the open for extension and clause for modification, which is also the second, which is a second principle that we followed in the solid design pattern. So what does this mean? Okay, so as maybe the sentence or maybe the principle itself explains what it's actually meant. So the open for modification, open for extension and close for modification principle is actually mean by it's actually mean our class or the class that we wrote or our code that we wrote, writing is it should be open for the extension, or we can say it in another word, we can scale, we should be able to scale that application at any level, but even without modifying a single file in our code. Okay, so that is what meant by the open for extension and close for modification. We should be able to modify, or we should be able to extend our application without modifying the existing one. Okay, so as we already say that the single responsibility principle, we wrote code in as a manner that each class should only contain one responsibility. So that if we wrote the user login, and we need to also we need to write the user first we wrote the user registration module, it's completed, and after that we wrote the user login module. So if we are writing in a manner that violates the solid principle, we can't achieve the second one. And if we completed that and we need to implement the login module, so it's a extension for our application, not modification. So if we want to write the login module, we can separately create another file, and we can write our implementation in that file or in that class. So it won't modify our existing class. It will be able to scale at any level. So that is what mentioned by, or that is what meant by the open for extension and close for modification principle. And the third one is that Liskov substitution principle. So this is very simple. The name is a little bit tough, but the principle is very simple. Liskov substitution principle is meant that if we derived a class from the parent class, so the derived class should be able to replace the parent class, or we can say it in another word that the derived class should be inherit or implement all the properties from its parent class. So that is what meant by the Liskov substitution principle. And moving on to the interface segregation principle, which is an interface or a class should not force to implement a interface it's a class should not be forced to implement an interface that it don't use. Or we can say it in another word, we can say I will say it in a simple word, which means that our class is actually the user registration, and we are writing the interfaces, like we wrote abstraction in object oriented, or if we are using text or something, we may mostly use the interface concepts, or also in the object oriented principle we follow the interface concept. So the while we are writing the authentication module and we writing in the user registration, so we usually implements that class from an interface. So there is something behind that. I will be able to explain that in the last point, that is dependency inversion principle. So in here we usually implements that class from an interface or from an abstraction. So the class if the abstraction contains more than two functions or properties, something like that, the class should implement all of them. Okay, otherwise it will violate the Liskov substitution principle. So if we are in the registration module, and if the abstraction or the interface contain the login function and the registration function in this class, or we can say in the registration class, we only use the registration function from that particular interface. So if we implement our class from that interface, it would not implement, or it will be forced to implement by default by the class a function that the class won't use. So this will violate the interface segregation principle. So that we should be write the code, or should be write the interfaces for each and every classes. So it will be very helpful, and it will be very flexible for use the classes and interfaces accordingly. So that is what mentioned by the interface segregation principle. And last and the final most important principle is the dependency inversion principle. So this principle is very simple but very we very aware of the principle. So the dependency inversion principle is actually says that each and every module in our application. So each and every module in our application should depend on the abstraction of the code, not on the concrete code. It should be depend on the abstraction. So which means that in our clean architecture or in any layered architecture, we follows an dependency inversion principle, which means that each and every modules depend, or each and every layer depends on one another. So then we can say that every lower level module should depend on the higher level module, not vice versa. Means that a higher level module should not depend on the lower level module, or we can say it in other word that a lower level module should depend on the higher level module, but they shouldn't be depend on the concrete code. They should be depend on the abstraction of the particular code. So that is what mentioned by the dependency inversion principle. So that is all about solid principle, and which is very helpful for every developers to build large scale application which are very scalable and maintainable, and also helps to build very robust object-oriented applications in real world. So that's all I have to talk in this video. Thank you.